Welcome back. The objectives of this video are to graph an exponential function using our graphing calculator, and we'll introduce the irrational number, the natural base, e. So right here are the instructions on how to put data into your calculator, into a couple of lists, and come up with an exponential regression. It's similar to the process that we have done in the past for other regression equations. I'm not going to run through all of that, but the process is the same, and then we will go ahead and do this on the graphing calculator. So example 6 says, use a graphing calculator to find the exponential equation that includes the points 3, 18.2, and 7, 94.7. So those are on our graph here. We've got a bunch of x values, we've got some y values. So when we enter this data into our calculator, we can steal our window from our x's and y's. We can also grab those from our ordered pairs as well. So it looks like we would use x's between 0 and 10 or 15, and y's from 0, and I would go over 100 for sure, since this is an exponential equation. So let's go ahead and enter this into our calculator. So we'll enter our x coordinates into lists, list 1, and our y coordinates into list 2, which is in the stat menu. So stat, edit, and I've got some other data in L1 and L2, so I want to clear those out. So I'll cursor up to the top, hit clear, and enter, and we'll get that data cleared out of there. And then we'll go ahead and enter our ordered pairs. So a couple of small lists. Our 2 x coordinates are in list 1. Our 2 y coordinates are in list 2. The next thing I'm going to do is set my window for my x's and y's. So my x's I chose between -5 and 15, counting by 2's, and my y's I went from -10 to 100, counting by 10's. And then I'll go ahead and I'll turn on my plot 1 and get that guy going. And if we graph, we might see our 2 ordered pairs there. Apparently I had another graph on that. I'll go ahead and turn that guy off for the moment. So now I only have my 2 data points in the data set. So I'll go back to the stat menu, and now I want to calculate the exponential regression. So I go under calc. Let's see if we can find our exponential regression here, and it's 0. And it's going to draw from list 1 and list 2. And I'm going to store my regression in y1 because I know that's an empty cell. So alpha f4, and I'll store in y1. I have another equation in y2, and I'll calculate my exponential regression. So my a value is 5.2828, and my b value is 1.51. It's stored in y1, and if I graph, it goes right through my data points, and there is my exponential regression. So now I've gone ahead and sketched my graph with a y-intercept of 0, 5.2828, right? If I put 0 in for x, my b value drops to 1. Anything to the 0 power is 1. 1 times 5.2828. So I've got my y-intercept graph, and there's a sketch of my function. Find the value where f of x equals 50, so we want an output, or a y, of 50. So this is the ordered pair something 50. So I don't know what my x is, but I know my y is 50. So I'm going to graph a horizontal line at y equals 50 and figure out what that corresponding x value is going to be. So I'm going to flip over to the graphing calculator and plug that in, and then we'll find the intersection. So there's the graph of y equals 50, And then to find the intersection, just go to Second Calc, Option 5, select the blue graph, select the red graph, enter, and we get 5.45 for our value of x to generate a y of 50. Now let's take a look at the natural base e. The number e is a convenient choice for many exponential applications. It's an irrational number, and it's used as a base in the function y equals e to the x, where e is about 2.71828. The graph of the natural exponential function shown at the right has the basic characteristics as the graph of the function y equals b to the x. Our base b is now just e. It's important to note that in the function f of x, that e is a constant and x is the variable. So just because e is a letter doesn't mean it's a variable here. It's that constant 2.71828. It does go through the point. The graph goes through the point 0, 1 and also through the point 1, e. So e is an irrational number, like pi is an irrational number. We can approximate the number e by using the limit formula below. So the limit as n approaches infinity of 1 plus 1 over n, that quantity all raised to the n, is equal to e. So that means the graph of this equation, if I put this in my calculator as y equals 1 plus 1 over n all raised to the n, the graph of this will have a horizontal asymptote at y equals e. So in example 7, they ask us to complete a table to see what the output values are when we input 1,000, 10,000, 100,000, and a million in for n, and what happens to these values. So I took the liberty to go ahead and put that function into my calculator under y3 here, and then use the table set value. So second window, second table set, and I start my table at 1,000. That's the first value that I want. And then go to second and table, and I can see when x is 1,000, y is 2.7169. And then I can go back to my table set, second table set, and I'll reset it, and I'll start my table at 10,000 and go second table, and now it tells me that y is 2.7181, and I'll repeat that process for 100,000 and a million and get the last values, put in 100,000, second table, and now it tells me it's 2.7183, and so forth. So I completed the table, and in B it says graph the functions y1 equals 1 plus 1 over x to the x, and y2 equals e. I'm going to steal my window from my problem here, so my y's I'll go between like -1 and 5, and my x's I'll go out to 10, and we'll see what that looks like. So down in y3 I have the quantity of 1 plus the quantity of 1 over x, close parentheses, all raised to the x. And then I'll do, in y4, I'll do y equals e, and the e key is above the division symbol there, one of the e keys, so second e, and check my window to make sure I've got what I need. Looks pretty good on my window, and go ahead and graph those two functions. And you can see here as our graph is approaching that magenta, that is our horizontal asymptote at y equals e. So we're getting closer and closer to e the whole time without touching it. So in graphing, I know that I'm going to go through the point 1, 2, because when I put 1 in for x, I'm going to get 1 plus 1 all raised to the 1, so that'd be 2. And x can't be 0, so I'm going to snuggle right up here to the 1, and my graph will look something like that. there's our introduction to finding an exponential equation using our graphing calculator and the irrational number e, and we'll get some more practice with this when I see you in class.